Is it visible? Okay, so morning to Nanda. Good morning. So in the last class we were discussing about the syllabus. So what are the content which is included in the Verilog syllabus we have seen. So as I already mentioned, so it is used for describing hardware. So this corresponding course has been included so that it is made the simulation part as well as the hardware interfacing part very much simpler as compared to the normal discrete circuits representation. So, Verilog HDL we are going to start, and the textbook which is prescribed for your syllabus is Samir Palnetkar. Okay, so a VHDL primer textbook title is Verilog HDL primer by Samir Palnetkar. So that is the textbook. So that is available for you. So four modules will be connected completely. All 5 modules will be covered by with that textbook itself. Okay. So in this we are going to have going to study from the module 1. So what is the introduction about the Verilog, how it started. So what is the necessity of starting that Verilog language, and what are the basics of Verilog language. So in the module 1 entirely, so we are going to cover about the what are the basics of Verilog language, and what do you mean by gate level modeling. So gate level modeling means gate level by using the logic gates you are going to build the circuit and you are going to represent. So that is gate level modeling. So data flow modeling, so you are going to represent the same hardware using expression type, so that how you are going to represent. So that is data flow modeling. Peer level modeling is nothing but a top level modeling of any digital circuit. So that includes behavior, based upon the behavior without knowing exactly the hardware structure. So if you can able to describe hardware, so that type of modeling style is called as a behavioral modeling. And finally we are going to learn in the 5th module about the task and function, useful task and function that is supported as similar to that of a high level language in C and all C++. So you are going to use a task and function, the same thing in Verilog also it is being supported. So certain routine task will be there, since we are going to use sequential circuits where it includes a timing signals to be calculated by every gates. So it has to be synchronized with the main clock signal. So we are going to use certain useful task. So what must be the time, duration, width, and the pulse width and all. So that is going to be learned in the task and functions. So some of the task and function. So when it started, so Verilog introduction as I told, so it was invented by Philip Morby in 1983 or 1984. So that is in the duration of 1983. So as soon as you can see that the basic first IC has been started, or the first transistor has been evolved in the 1947. After that 1960s, 1970s and also they started building them IC circuit. So IC circuit was very in the small scale. So that means very small number, hardly 2 transistors, 4 transistors might be they might have used for building an IC circuit. But as the year progressed, so that means more and more number of transistors started embedding on the chip. So at that time, so 1983, 84 and all, so they started finding it difficulty. So finding it difficulty in the sense manually it is very difficult to check all the circuits inside the IC. So before it get fabricated, so there was a very misconception was there. So there is difficulty was there. So that made the Verilog to introduce, so that like how the basic Pascal, C, all those things, higher level language was there in the software field. The same way they started thinking about how we can able to describe the hardware. So it was the first gateway design automation, that is a company. So in which the Philip Morby, so he started thinking and he started doing certain language, so which is be suitable for the hardware describing. So which enables specification of digital system at a range of different levels of abstraction. So the purpose of Verilog language was very clear that at different levels of abstraction, so it has going to be supported. That is from the basic transistor level till the higher level. So it they started thinking that we can able to describe the hardware in any levels of abstraction. For that purpose, so they started thinking of describing the hardware language, that is Verilog. So initially developed with the conjunction with Verilog simulator. So initially it was Verilog simulator language they started. So I will just tell the what is the standard as well as how it is being gained acceptance in the wide range of VLSI customers. So Verilog based synthesis tool. Synthesis tool means normally, so in IC, so we are going to learn about what is the physical design, floor planning, placement, routing between the gates. So a bit different combination of big circuits will be there. So in the big circuits, so how we can able to efficiently route between the number of transistors, because all the circuits requires power supply. So that power supply is also very important, along with that clock. So clock is required for any of the operation, because if clock is not synchronized with any of the circuits inside that, so we will be not able to get the proper output. So efficient placement, floor planning, routing, and then after routing and all, so we need to efficiently check how much power consumption it is going to take place and all. So for that, so we need a tool so that before fabricating, so we can able to get approximately, so we'll be not getting exact what is after implementing how much you will be getting the power consumption and all, so we'll be not getting exactly, but approximately we can able to analyze before fabrication itself. So for that reason, so they started with the introduced Verilog based synthesis tool was introduced along with the Synopsys company. So introduced by Synopsys in 1987. So in 1983, 1981. So this is an all brief history. So you don't need to scratch your head. So only thing is that as the transistor size, as the number of circuit size keeps on increasing, circuit size keeps on increasing, so it became difficult for manually testing because it was time consuming. So time consuming means what? So time consuming means more number of users are required, and if the circuit size is very much high, so much complexity was there means, so it was taking hardly so more number of time. So more number of time in the sense in terms of years it was taking. So in order to reduce the time, because market, so in order to place a market, so we need to manufacture IC, so it requires the components to be promoted to the market with high efficiency. So for that they started with the Synopsys and Cadence. So you can see Cadence is the one tool, as well as Synopsys is one of the tool industry VLSI standard. So apart from these two tools, so Mentor Graphics, Xilinx, so which we are going to study in the lab is nothing but a Xilinx tool. So Mentor Graphics, so that is another one tool is there which we can able to describe the hardware. So these are all the basic core companies where we can describe the hardware. So Verilog placed in the domain with the VHDL in the market. So it is IEEE standard. So IEEE standard means it is being widely accepted by the all by the international international standards, so that is IEEE. So having the number 13642 2001. So up to that it has been widely accepted by the end customers as well as the end users as well. So next is we have to see what is the design flow. So for whenever you are going to design any circuit, so what is the Verilog design flow that you need to consider? Suppose if I want to take an example of a full adder itself. So in order to build the full adder, so what and all things from the scratch, from the beginning till it goes to the end. So we need to think. So what is the design flow of a Verilog for any digital circuit design? So this is the first we need to know what is the design specification. So whenever we give any circuit to build, so first thing what you are going to see. Suppose if I want to tell you full adder, so full adder design ಮಾಡಿ ಅಂತ ಕೊಟ್ಟಾಗ, so what first initially what you will be thinking? Full adder, without knowing full adder, so what you will be thinking? So you will be thinking about what is the description? That means full adder means what is the usage of this full adder we are going to analyze. So usage means what? So how many inputs are there? So what is the output? So first we should consider a black box representation. So this is what the black box representation. So as a beginner, so before full adder, how they have described the circuit. So that is what the design flow. So finally, I want full adder as an IC form. In an IC form, I want a full adder IC, but in order to make it into the end of the fabrication of a full adder IC. So IC you have seen, right? So 74186 or 74153. So where you have used the counter IC in the digital circuit, right? So 74153 usage of that counter to form it as a full adder, right? Madidira illa. So in order to realize the full adder in the form of using the 74153 IC you have used. So the same way, so in order to get the full adder as a final product in the IC form, so from the beginning what you are going to have. So first we need to have the design specification. So design specification means, so you should know what are the important concepts like what is inputs and what are the outputs for any circuit. So any circuit, so we should know any input per so what is the output you are going to get. So finally, and then correspondingly next what we are going to see. So whether it can be realized. So how we can go. So we can realize that circuit using truth table. So what and all the things which you can fulfill to realize the full adder. So that and all supporting things we are going to learn. So that means full adder concept. So we have to see that ABC. So 000 so what is the output? So 00 you should get. So that is what you are going to write the truth table in terms of that. Because before writing exact hardware, so you are going to test by writing the truth table. So after once the truth table is done, so next thing is that you are going in detail. So in detail means, so how we can realize in terms of circuit wise. So circuit wise means can be able to implement any logic gates for that to do or not. So that is what the design specification. So first we are going to see that what is the inputs and what are outputs, and behavioral description. So behavioral description is what? So what are the different test cases, how I should get the output. So full adder nಮಗೆ general ಆಗಿ ಗೊತ್ತಿರುತ್ತೆ. So full adder means what? It whatever I give the adder, so I should get the inputs, whatever I give the inputs you should get the corresponding output. That is nothing but the adder circuit. So subtractor and the subtractor, so it should give, so A, B minus C. So if I want to give, so it should add and it should get subtracted with the C. It means, so what is the corresponding difference and borrowed you should get. So that is what the design specification. So next thing is that behavioral description. So once the behavioral description is being done, so next thing is that, so how we can implement in terms of logic gates. So logic gates, so that is RTL description. So where you are going to use a hardware description language. So before explaining this, I will just give one logic gates, because you will not understand if I tell the flow. So first I will tell one by very one logic gate. How we can write AND gate. So beginning. So AND gate first I should write what is the symbol of AND gate, right? This is the AND gate symbol. So A and B are the two inputs and Y is the output. So after that what you are going to write? So this AND gate is the symbol. So next thing is that, so you have to check whether functionality, behavior description. So behavior description is nothing but A, B, Y, 0, 0, 0, 1, 1, 0, 1, 1. So this is what the behavior of AND gate, right? So when I am giving 0, 0, when any one of the input is 0, we will be getting output as 0. So when both the inputs are 1, 1, I should get output as 1. So that is what the behavior of this AND gate. Okay, so now once I get this AND gate realization, so next thing is how I can implement. Because design flow I am telling, so design flow is nothing but, so next thing is what? The RTL description. So RTL description is nothing but the STL programming. So how I can write in terms of hardware description language. So for that I am going to use a Verilog. So whenever you are going to start with any hardware description language, so in Verilog you are going to call with the keyword module. So beginning, it should have a module. Any complex circuits or any circuit if you want to realize, you have to start with module and at the end you should have end module. So any circuit, so for my circuit I am taking it as a AND gate. So whenever I am going to write the AND gate realization, so I should write within module and end module. Okay, so once the module has been written, so next thing is followed by the name of the module you should give. So this is module followed by the module name. So this module name should not be same as that of the libraries which are going to use. So this since I am taking this AND gate, so this AND gate it is already in the libraries. Okay. So OR gate, that is nothing but the keywords. So instead of AND gate, if I take this AND, so it is already available in the library. So for your understanding, I am just going for this AND gate. What do you mean by AND gate and how I can describe this AND gate in terms of hardware description language I am showing. So I am taking instead of AND, if I take it is already available, so it cannot be taking as a module name. So I should use a different name. For my understanding purpose, I am going to use the name as AND gate. So this is module name. So after that, we should have a parenthesis. So within this, you will be having a parenthesis. So where you have to define what and all the input and output. So whatever inside the structure is there, so no need to bother. That means if I am going for a full adder, so full adder on the command line, so I am not considering internal connections. Suppose XOR gate 1, first XOR gate input, output of first XOR gate is even connected to the second XOR gate input. So that I don't know. So only I will be writing only what and all the inputs are there, what and all output are there. Intermediate connections, so we are not going to write. So here always make a habit of writing the output. So this is the output. So for AND gate, so this is the output. These two are my inputs. So I am going to write Y comma A comma B. Okay. So followed by that, we have to define. So next two things important is what we mean by the output ports, which are output ports, which are input ports we need to write. So for that, we are going to define a keyword output. Output. So for my program to describe AND gate, so what is my output? So output is Y. Only one output is there. So if multiple outputs are there, so you have to define all the outputs. Suppose if it is a 1:4 debugs. So 4 outputs will be there. So Y0, Y1, Y2, Y3. So like that, any number of outputs if it is there, so you have to write the output. So next is what? Input. Input is A comma B. So after writing module followed by module name, so define what are the parentheses and Y comma A comma B and output as Y, input as B. So these things it has to be there. So next thing is, so within this you have to write the functionality of the hardware. The hardware in the functionality we should write here. So this functionality I can write in 4 different ways. What are those? Behavior level, next is data flow level and gate level, switch level. That means in this hardware describing language, so I can make use to describe the hardware functionality in this portion. So when I am describing this, I can write in 4 different ways. I'll show. So all the four ways for this AND gate I can show. So first thing is behavior level. So I'll go differently. Okay. So I'll go differently. From switch level I'll go till behavior level because behavior level and all. So the program will be having lengthy. So switch level. So switch level means what? Transistor level and gate. So and gate, so I will be knowing Indra. A, B. Okay, so this is nothing but your AND gate realization. Whether it is AND gate, we need to check, right? How I written. So this is CMOS logic AND gate. CMOS AND gate. So here you can see this is the ground. These two are NMOS logic. So I am going to give as NMOS 1, N2, N3, P1, P2, P3. So three transistors. So if I see here, the output will be Y bar. Y bar ಅಂದ್ರೆ ಏನು? AND gate ತಗೊಂಡಿರೋದ್ರಿಂದ Y is the output of the AND gate. So Y is what? A dot B. So this is what you are going to get the logic AND gate. So ಇಲ್ಲಿ ನಮಗೆ ಏನು ಬರ್ತಾ ಇದೆ? AND gate ಬರ್ತಾ ಇದೆ. Y bar is nothing but A dot B whole bar. So that is NAND I am getting because it is a complementary logic. So I will be getting A dot B bar. So for that I am going to add one inverter over here using PMOS and NMOS. So now, ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ ಇಲ್ವಾ? So here I need to write the functionality. So in order to write this functionality, I can write in the AND gate with four different level. So for this four different level, I have started with the switch level. At the bottommost level, that is the description. So this is nothing but your AND gate. Because A and B I am giving as input, I am getting output Y as the output. So for this output, if I give the truth table, according to my truth table, if you check, suppose 0, 0, 0, 0, what is this? NMOS. So NMOS works with the positive voltage. 0 is negative. So in terms of logic level, if I speak, so 0, 0 means both will be in off state. So here both will be in on state. So on state I told that since it is connected to VDD, so you will be getting output as what? 1 VDD. So VDD you will be getting. VDD in terms of logic level if I speak it is 1. So this 1 is being given as input for both these two. So since it is 1, so this will be off. Since it is 1, it drives this transistor because it will be on. Since it is connected to ground, so output will be 0. So that means when I am giving A and B as 0, I am getting output as 0. The same way, if I change for 0, 1, 0, 1, 0 means it will be off, 1 means it will be on. But since the ground is connected here, since the input is given as 1, this will be, even though it is on, so this value it will not reach here. Why? Because this is in off state. Whereas the same thing, A is equal to 0, B is equal to 1. So this will be on, this will be off. Correct? 0 means on. For this B is equal to 1 means this will be in off state. What is the output over here? because the VDD is connected in parallel, even though it will not come reach here through this path because it is in off state, because it is acting like a open, but here it will be closed path because it is on. So VDD will come here and it will be coming over here, VDD. From VDD, here it will be 0. So second case is also verified. So third case, just opposite, 1, 0. So this 0 means this will be off, there is no reaching point. This is 1, 0. So this will be in off, but since it is on, so VDD through this path it will come and VDD will be getting from here to here, it will get 0. So this is also verified. So last case is what? 1, 1. So 1, 1 means both the transistors are on. Correct? 1, 1 means both will be off. So since both the transistors are on, so from here ground, the value will reach to the output. So what is the output? 0. This 0 will drive this transistor and this will be in off state. So this 0 VDD to here will be getting output as 1. So will be getting output as 1. ಈಗ ಸರ್ಕ್ಯೂಟ್ ಬರ್ತಾ ಇದೆ. So this is AND gate. Correct? Truth table verify ಮಾಡಾಯಿತು. So now this how I can describe here. Describe ಮಾಡಬೇಕಾದ್ರೆ so for that describe. So you require supply 1 power, supply 0 ground. Any power and ground. What do you mean by this? Supply 1, supply 0. So these are the limit of power supplies. This is what? Supply 1. This is what? Supply 0. So these are nothing but the keywords which is available in the Verilog library. So when I am going to use supply 1, so I am going to give it as power. Power signal is nothing but VDD. So supply 0 is nothing but ground. Okay. ಇವಾಗ ಈ ಸರ್ಕ್ಯೂಟ್ this circuit I am describing in Verilog language. So this is what the Verilog description, right? Functionality describing of a hardware. The hardware I am describing here. So how many transistors are there? PMOS, P1, P2, P3, N1, N2, N3. Right now, ಇವಾಗ ಇಲ್ಲಿಂದ ಫುಲ್ ನಾನು ಡಿಸ್ಕ್ರೈಬ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. AND gate ಅನ್ನು ಡಿಸ್ಕ್ರೈಬ್ ಮಾಡ್ತಾ ಇರೋದು. So how many transistors are there? PMOS, 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 NMOS, 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 followed by P1, P2, P3, N1, N2, N3. So now, why I have written all at a time is because, so this is the thing where you are going to describe the AND gate in switch level. So switch level is nothing but a transistor level. So now PMOS P1. So along with that, you should write how the connections are being done. Okay. So when you look over here, so here is what? VDD. Here it is what? The output. So normally the transistors will be having 3 terminals, right? Yeah, terminal. Emitter base current I know. So this is drain, source, gate. Drain, source, gate. So for this, always you should remember Any output is there, you are going to connect drain. So this will be drain, this will be source. For this N1, this is source gate. Always the source need to be connected to the power supply. So you can see for positive power supply, source is being connected to VDD. The same way for NMOS, source is ground. So for that, I will be writing source here and drain here for N2 and gate. Okay, so here I am going to establish one contact, right? For this transistor and this transistor, I am going to write establish one connection. So I am giving that as Z. I should name, right? So I am going to give the connection between the N1 source and N2 drain. I am giving it as Z. Whether you following? Okay, so this output from this circuit I will be giving as Y1. Here one term is right. So where these two drain has been connected and this drain of N1 is being connected. So I am going to give that name as Y1. That is where the joint antara, junction antara, junction antara. Okay. So where 2 points if it is meet, it is a joint junction. Okay, junction. So this junction Y1. Why I am telling is, so now when I am going to write here, so it is required. So Y1 is being connected to these two transistors and finally I will be getting Y as the output. So now, why I told all these things? Because now you should tell for PMOS always whenever you should have the format drain source and gate format. So now PMOS, you look into that circuit, this PMOS, P1 transistor, drain is connected to what? Yes. Drain is connected to Y1 followed by source is connected to VDD. Here it is power and gate semicolon. So always whenever we are going to use a semicolon, what is that? It will be treated as in simulator. See again end of one single line. So next line also. So the same way here also whenever we are going to put a semicolon, so that is treated as that sentence is over. So go for the next statement. So again it is P2 drain Y1 power B P3 is there. Output is Y, source is power, gate is Y1. The same way N1, N2, N3. NMOS, N1, drain, source, gate. So N1 drain. Drain is Y1. NMOS, N2. N3. Everything is left out in the given circuit. Anything is left out. It is left out. defined. Z is there, Y1 is there. It is not defined in my program. Correct? So apart from that, everything is over, right? I have described the hardware of AND gate. Any difficulties there? Normally, this is what you are going to learn in the entire course. HDL means only this syntax you have to learn. So module name, code, what is code difference. After that, you have to write the functionality of the hardware followed by gain module. This is what Verilog. This is very easy subject. I am telling you, very easy subject, and compared to other subject in this semester or whatever subject I handled before, two subjects, it is very easy. Scoring is very easy. ಏನಿದೆ ಕಷ್ಟ ಆಯ್ತಾ? ಕಷ್ಟ ಯಾಕಾಗಿಲ್ಲ ಅಂದ್ರೆ, so this circuit has been defined over here. A circuit total I have described over here. So this circuit is what? AND gate. So that AND gate I have described here. So this is called as hardware description language. So ಇಲ್ಲಿ signals ಅಂತ ಬರಿಬೇಕು. So I should write signals as what? Y1, Z. So this you can write later also. So once you describe what is left out, so then later you can write it down here. This is one way of representing the hardware. So next is what? 4 ways I told. One is switch level and the next is what? Gate level. So you are going to the switch level version. So I shall have this one. End module. This is all end module. There should be no space between end and module. So continuous. Okay. So last one of that one thing. So all the three left out will describe the respect to end. Okay. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಇದನ್ನೇನು ಅರ್ಥ ಮಾಡೋದೇನಿಲ್ಲ, ಸಿಂಟ್ಯಾಕ್ಸ್ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಷ್ಟೇ. Okay, thank you. ಅಟೆಂಡೆನ್ಸಿಗೋಸ್ಕರನೇ ಬರೋದಲ್ಲ.